Good. Welcome to Math 162. Let me introduce myself. I'm your instructor. I'm Dr. Joseph Chen. A little bit of background about me. I have a degree from Purdue. I got my PhD in aerospace engineering back in 2010. My office is in Math Building, just across the street, across the walkway over that way, room 848. Take the elevator up and turn right. I'm just right around the corner. My email is chenjk@purdue.edu. And what's going on there? It looks like the resolutions were messed up. Let's see if we can fix it quickly. That's better. All right, so let's start with my other screen. There. All right. Okay, so let's start from the beginning again. I'm Dr. Joseph Chen. I'm your instructor. My office is in Math Building, room 848. My email address is chenjk@purdue.edu. My office hours, officially Monday, Wednesday, Friday, 9 to 11 a.m. But anytime my door is open, I will talk to you. You want to come and talk about the course, about homework, about whatever you want to talk about, I am open, and please come in and talk. The course webpage is a very important resource for this course, math.purdue.edu/MA162. On there's all the information you will need to know about this course. And I'll talk a little bit about what's on there, but please do check it out when you get a chance. So right now, we're going to go through the course policy briefly. But remember, it's your responsibility to read what I have posted on the course webpage and ask questions if anything doesn't make sense. So once again, everything you need to know is on math.purdue.edu/MA162. First, the textbook we use is Calculus Early Transcendentals, 7th edition by James Stewart. I have a picture of the book on the upper right corner of the PowerPoint. You see it's a white cover with an S on it. You will need access to WebAssign. See the course webpage, again, at math.purdue.edu/MA162 for more information about WebAssign. Let me show you what it looks like. So this is the course webpage. You go down a little bit to assignments. You'll see WebAssign login. All you need to do to register for WebAssign for this course is simply click on that WebAssign login. You don't know which section you should go into and put you in the right course automatically. So that's just a one-click thing and very easy to do. Okay, eventually you have to pay for WebAssign. That money goes to WebAssign. Purdue gets none of that. That's their thing. Okay, they set a price. We have nothing to do with it. However, there's a 2-week trial period during which you don't have to pay. So the first 2 weeks of the course, you don't have to pay anything to use WebAssign. That's to give you a chance to see if the course is right for you. If you do leave this course for whatever reason, then at least you are not out that amount of money. And the last I checked, they're asking for $79 for a single term and $118 for Life of Edition. Life of Edition means if you take another course using the same textbook, that access is already paid for. Single term means single term, just this semester. You can ask me questions on WebAssign, or you can ask your recitation TA whom you will meet tomorrow about web assigned questions. The textbook itself, the physical textbook, it's not really strictly required because once you get into web assigned, they give you access to the ebook. It's a very high quality ebook. So really you don't need to have this big 6-pound book right here if you don't want to have it. If you want to have a copy, that's fine. You can save some money by buying a used, older edition because calculus really hasn't changed that much between 6 and 7, trust me. All right? Okay, calculator policy. No calculator is allowed on exams and quizzes, so make sure you know how to do some of the most basic things. On exams, we're not going to ask you to calculate sine of 42 degrees to the 7th decimal. We're going to be reasonable, okay? A couple homework problems may need a graphing calculator. If you don't have one, there is an online one that I found that's pretty easy to use, and I put a link on the course webpage. So check it out if you ever need to use one and you don't have one. There are 36 online assignments using WebAssign. And the link, the login link, that's the same one that's on the course webpage. That's the one you should go to get into WebAssign every time you want to use it. Homework from Friday and Monday lectures are due Tuesday at 11 p.m. So today we're going to start lesson 1 in a little bit, and the homework that goes with that lesson is due tomorrow night at 11 p.m. And Wednesday, when we go over the lesson again, the homework that goes with that is due on Thursday night at 11 p.m. Friday lecture, homework is due the following Monday. Exceptions are things like Thanksgiving break, October break, and check out the course calendar on the course webpage to see due dates and things like that. Okay, we don't accept light homework, so we will automatically excuse the lowest 3 homework assignments for whatever reason. Okay, so if you, for some reason, missed one, don't worry about that. The first 3 are not going to hurt you. If something happens that's beyond your control and you need to have more excuse, talk to me. Tell me what happened, and we'll work something out. Just explain it to me. We're very reasonable people at math department. Okay, a quiz in almost every recitation class. Now's a good time to show you the calendar again. Well, first time, I guess. Okay, so here you see the calendar here. It tells you what we're doing every single day and what to be prepared for every single recitation. So today you can see lesson 1, 12.1 and 12.2. Tomorrow, you have your first recitation. There's no quiz tomorrow, but homework 1 is due tomorrow. Wednesday, we're doing 12.2. And Thursday, the second recitation. Be prepared for the first quiz. That's going to be over lesson 1. And homework due is that night at 11 p.m. And similarly, no makeup quizzes will be given. But just like homework, we'll excuse the lowest 3 for whatever reason. If you need more, talk to me. Okay, so write these down right now. The 3 exam dates and time. The first one is on Thursday, September 17th, 6:30 p.m. Location to be determined. When we get closer to it, I'll let you know where the exam is. These are all 1-hour evening exams. They're multiple choice. Exam 2, Thursday, October 15, 6:30 p.m. Exam 3, Thursday, November 12, 6:30 p.m. So they're all on Thursday, and they're all at 6:30 p.m. If you miss an exam for whatever reason, contact me right away. Explain what happened, and usually I'll let you take the makeup exam. All right, so those are 3 exam dates, and then, of course, I will announce and remind you as we get closer to each one of them. And these are also posted on the course webpage. All right, so how do we calculate grade? Everything is based off of 700 points. You get all the homework you do put together is worth 100 points. So if you get perfect on every single one, except possibly the lowest 3 that we excuse, then we'll give you 100 points toward the 700 point total. If you get perfect on every single quiz, possibly, except possibly the 3 lowest ones we excuse, then we'll give you another 100 points. Each of the midterm exam is 100 points. So you get 300 maximum out of the exams. And then the final is a 200-point final exam. So the absolute maximum you can get is 700 points. We have no preset letter grade cutoffs for letter grade. But generally, you will need about 90% to have a realistic chance at an A. Sometimes lower than 90, could be 85, 87 kind of thing. But it's a conservative estimate is a 90%. If you get a 90%, you're pretty much going to get an A. If you have anything lower than a 50% in this course, then you are not doing so well. If you have less than 50 or at 50, your chance of passing the course is not very good. Okay? But the actual cutoffs for A, B, C, D will differ from semester to semester. After every exam, I'll give you an estimate of up to that point what an A would be, what a B would be, what a C would be, and so on, after each exam. And anytime during the semester, if you want to know where you stand, let me know or let your recitation TA know. We're going to try to help you figure out where you are, how you're doing in the course. Make sense? Okay, so 90 for an A, 50 for a D. Then you might ask, what do you need for a B? Well, it's irrelevant because everybody's getting an A, right? Now, shoot for the 90 and you will be in good shape. All right, so we have to talk a little bit about cheating policy. The short version is don't do it. The slightly longer version is if you cheat, don't get caught. Yeah? Now here's the longer, more official version. Right. Purdue prohibits academic dishonesty. According to university policy, cheating, plagiarism, lying, and deceit in any of their diverse forms, such as the use of a substitute for taking exam, the use of illegal crib, plagiarism, and copying during examination, is dishonest and must not be tolerated. Moreover, knowingly aid, abet directly or indirectly other parties in committing dishonest acts is in itself dishonest. If found guilty of academic dishonesty, possible penalties are not very pleasant. Failing grade, warning, probation, probated suspension, or expulsion. For more details about the policy on academic dishonesty, please see the link at the bottom. It's easier just to Google Purdue academic dishonesty policy. I'll take you straight there. Okay, so the point of this is we have zero tolerance policy on cheating. If found, we will turn you over to the Dean of Students. And they do these unpleasant things. Okay? And then we know that the vast majority of you will not cheat, but you worry about other people cheating in the course, and therefore hurting your work and your accomplishment in the course. So we have a very stringent policy, mostly to put your mind at ease, to let you know that we are aware of cheating and we will take very serious action if we catch someone cheating. Okay? So trust us, we're looking out these things for you. You just worry about doing your best on exams and quizzes. All right, so Purdue has academic adjustments for students with disabilities. Purdue is an equal access, equal opportunity university. So we provide adjustments for students so that they have the same chance at succeeding in any course at a university. So if this applies to you, you have talked to a Disability Resource Center or will be talking to them and have been in contact with them. You will receive a few copies of the accommodation notification memorandum. Please deliver one copy to Math 242 and request an information sheet for the course. Please deliver that within 1 week of receipt from the Disability Resource Center. And Math 242 will tell you everything you need to know on getting accommodation on exams and quizzes. If you're currently undergoing evaluation, please go ahead and talk to Math 242 anyway and get more information if you have questions. If any of this is not clear and this applies to you, please speak to me. There are supplementary instruction study sessions available for this course. These are student-led sessions. They're led by students who have taken this course and have gotten very good grades in this course. It is open to anyone in the course. Attendance is completely voluntary. Please go to purdue.edu/SI to find out times and locations, or check out the Boiler Guide app. They have all the schedule on there too. So a little bit on Wednesday, there will be representatives from SI telling us more about this. So let me give you just a little bit about what these things are. They are interactive sessions, and you'll work with other students in the sessions comparing notes, discussing problems and concepts, and generally work in a more interactive way than in lecture and recitation. If you do attend these, please bring your ID card, lecture notes, and questions. And once again, on Wednesday, you'll find out a lot more about SI. So let's wait a little bit on this until Wednesday. Like I said earlier, Purdue is an equal opportunity and equal access university. Purdue is also a welcoming university. We welcome every single one of you, regardless of your background, of any sort of background. And we found this poster, and I thought it's really good. It says that you are an important member of a world-class university that values all people, the free expression of ideas, diversity, and acting with integrity. We're glad you're here. So we do take your ideas, your expression of ideas very seriously. But if you tell me 2 plus 3 is equal to 6, then I'm not going to take that too seriously. So this is not an easy course. I'll tell you that right up front. We'll start with some of the easiest material in the course, but the middle or maybe even the last third of the course is generally considered very difficult. So start off right. Get yourself in a good habit to prepare for the later part of the course. We have a lot of help available for you. We have what's called a math help room. It's in the math building in room 205 and 211. They're staffed by graduate TAs or highly qualified undergraduate TAs who can answer homework questions and concepts or things that you're having trouble with in the course. Of course, please take advantage of my office hours. They're Monday, Wednesday, Friday, 9 to 11, or pretty much any time you can find me in my office. Also, your recitation TA's office hours are also very valuable. Please do use them. Supplemental instruction. There are also evening Science Help Center hours available. Monday and Wednesday, 7 to 10 in Shreve Hall Resident Support Center, and Tuesday, Thursday, 7 to 10 p.m. in Harrison Hall Conference Room C10. And all my lectures are recorded, and they're available via Boilercast. Go to the course webpage and look at it. Just follow the instructions, and it'll show you how to get the recording of all the lectures. So everything I'm doing right now is recorded. Everything I'm going to be writing on the DocuCamp is recorded. So I really have to watch what I'm saying. Okay, so Purdue is a very safe place in general. Okay, but just like when you get on a plane, you have these flight attendants telling you all the very unlikely events, if they happen, what you should do. We should also be prepared for the very unlikely emergency events. So the obvious thing, if you report an emergency, call 911. If you have not done so, please sign up for emergency text alert. Go to purdue.edu/EA. If anything on campus happens, you get a text and email telling you where it is and what it's about and what areas to avoid. So many of you, I'm pretty sure, saw this thing in action on Saturday night when we got like 3 in a row. So that's, now the point is, okay, that 2 of those turned out to be nothing, but it's good that we knew that they happened and we could be aware of it and be prepared if something does turn out to be unpleasant. There are nearly 300 emergency telephones outdoor across the campus. There are those things with a blue light on them. If anything happens, push it, and Purdue Police will get on there and help you out. If you hear a fire alarm, we will immediately suspend class, evacuate the building, and proceed to the northwest portion of the Purdue Mall. That's our primary evacuation location. If the weather is not good, we will go to the recitation building. If we are notified of a shelter-in-place requirement for tornado warning, we will suspend class and shelter in the lowest level of this building, which is this level, I'm pretty sure, and away from windows and doors. And this is a pretty good place. I don't see any windows. Doors, fine, but we'll be okay in here. If we are notified of a shelter-in-place requirement for other events, such as hazardous material, civil disturbance, active shooter, we will suspend class and stay in this room, turn off the lights, lock all the doors, and we will try to find information using our phones, computers, whatever. So here's a map of the primary location. It's that red star here. We're in the center of that map, CL50. If we hear a fire alarm, we'll head straight out and go to the northwest part of the grassy area. If the weather is bad, we'll go into recitation building. Okay, so that's a very quick intro of the course. Please go to the course webpage and read all the things I posted and ask questions if anything is not clear. Are there any questions right now? Yes. I can email them to everyone. Okay, I'll send the slides to everyone by email after class. Other questions? Yeah.
I recently logged into WebAssign and it gave me the wrong instructor. Is that for that matter?
What does it say?
It says that I have Derek and Percival as my instructor and I'm the second.
Yeah, so that's your recitation TA. And the way we set up WebAssign is that they're by recitation. So that's the right information, and it's fine. Other questions? Okay, my second string is not not behaving. Okay, I think we are good. All right. Okay, so today we're going to cover sections 12.1. It's a very short section. It's a pretty simple one. It's an introduction to three-dimensional coordinate systems. So we're all familiar with two-dimensional coordinate systems. Just the x and y axes, right? Now what we're going to do here is to add one more dimension to that. So this is a 3D kind of perspective look of it. The x and y axes form think of it as the floor of this room here, and z is the height of this room. Right? So I'm standing on the xy plane, and when I point up, that's the z axis. So adding one more dimension to what we already know. Now, one thing we need to find out is the shapes that we're familiar with in 2D. What happens when they go into the 3D dimensional system? For example, in the two-dimensional world, y is equal to 5 is a straight line, right? It goes through the point y is equal to 5 and just stays horizontal. That's y is equal to 5. In the three-dimensional world, it's kind of the same idea, but we got one more dimension to worry about. If you think about it, when you say y is equal to 5, we're saying that we want all the points possible such that y is equal to 5. So in other words, we want to collect all the possible points that look like that. X, comma, 5, comma, z. We don't constrain what x and z are, but we constrain what y is equal to. Here's what we end up getting. This is y is equal to 5. So everything sitting on the x and y plane, that's y is equal to 5, right? So all of these dots I've drawn are all the possible points with y is equal to 5, but x can be anything. In addition to that, we also have to consider the z dimension. In this case, z can also be anything. So we're going to consider all the points sitting just above it, all the points sitting just below that, and we keep going until we accumulate all of these possible points with y is equal to 5. So what do you think the shape ends up being? It'll be a plane. Yeah, very good. It's a plane. It's an infinite plane, by the way. So that line in the middle, that's our usual y is equal to 5 line. And then everything above it, everything below it, and everything extending to the positive and x infinity for x and negative infinity for x. Does that make sense? You take a line in the two-dimensional, you blow it up, one more dimension, you get a plane. Okay? And now we're going to look at what happens in the three-dimensional world if I specify two numbers instead of just one. When we specify one number, you saw earlier, we ended up getting a plane. Now we specify two numbers. The way to think of this is to think of it as the intersection of x is equal to 3, which is a plane, and y is equal to 8, which is also a plane. Right? So that's equivalent to saying, first draw me a plane at x is equal to 3, and now let's narrow this down and only consider the parts with y is equal to 8. And what do you get when two planes intersect? You get a line. Yeah. Look at the wall and the floor. The intersection of the plane, that's the right wall here, and the floor here, it's a line, right? Same thing here. First we have x is equal to 3. And by the way, it's very hard to draw a three-dimensional thing on two-dimensional paper. But I'm trying my best. Right? So there's my x is equal to 3. And then my y is equal to 8. It's very hard to do. Okay, but you can kind of see where they intersect. Somewhere over here, it looks like. There's our line. So that's the intersection of these two planes to get our line. What happens if I specify three numbers? What do I get? Just a point. Yeah, exactly. If I tell you z is equal to 5, that's just one single dot. That's also equivalent to intersection of three planes. That's when the two walls here meet the ceiling, right? There's our one corner there. That's our one point when three planes intersect. The nice thing about three-dimensional coordinate system is that most of what you know about two-dimensional coordinate systems translate to 3D very naturally. For example, the distance formula distance between 2 points, let's say x1 comma y1, and x2 comma y2. Right? We all know this. This is just the difference in x squared plus the difference in y squared, and everything under a square root sign. In three-dimensional world, each of these points will get one more number attached to it. So the 2 points we end up looking at look something like that. And you take your two-dimensional distance formula, you add one more part to it to account for the z component, and you get as what you would expect. The difference in x, the difference in y, the difference in z, all of them squared, added together, and then put them under a square root sign. All right? So what do you think a four-dimensional distance formula will look like? Exactly the same with another part added to it. But what a four-dimensional thing looks like, that's a different story. We can calculate the distance. It's not difficult. But to describe what we're actually working with in a four-dimensional world, that is difficult. Another example of things that you already know that apply directly in a three-dimensional world is when you have a circle with a center at h, comma, k, and a radius of r. And we get this formula in a two-dimensional world. A circle in two-dimensional world, if you move it to the three-dimensional world here, a circle becomes a sphere, right? And the center is at h, k, and we'll use L for the last one. The radius is still r. So here's another instance. You take what you already know in two-dimensional world. You do the obvious thing to account for the new dimension. And so we get this formula here. And we get a sphere with a center at HKL and a radius of R. For example, if I take this, just make up some numbers here. X plus 4 squared plus y minus 4 squared plus z plus 1 squared is equal to 4. Okay, and then we look at these numbers to find out where the center is, and just remember to change the sign. So center is at -4, +4, and -1. And of course, radius is 2. Here's an interesting question. If I have this sphere sitting here, and I want to know what its intersection with the xy plane is, what do you think? Close. On the xy plane, x is not necessarily 0. Y is not necessarily 0. So, but z is 0. Very good. Right, z is equal to 0, right? So when I look at this formula, I just do x plus 4 squared plus y minus 4 squared. Z is now at 0. So that becomes a plus 1. So I end up getting this thing here. Yeah, it's a circle, right? With a center at minus 4, 4, and a radius radical 3. Think about when you have any random sphere and then you slice right through it and you look at the cross section. That's what we're seeing right here. Okay, next we're going to look at just part of section 12.2. We'll continue with section 12.2 on Wednesday, but today we'll look at just the beginning part of it. In 12.2, we'll look at what's called a vector. Simply put, a vector is something that has a magnitude and a direction. As opposed to scalar, which only has a magnitude. Okay, as an example, if I tell you my dog is 4 years old, that 4 is a scalar, right? It's a number with a magnitude. He's lived on this earth for 4 years. That's it. But if I tell you my car is going northwest at 65 miles per hour. Now that information now has a direction and a magnitude, how fast I'm going and where, which direction I am going to. So this is a vector. And the way we represent vectors is to use arrows. So for example, if my vector A. So notice the way we write it, the vector name, whatever you want to call it. And you put this arrow over that to indicate that it is a vector. So the vector A looks something like that, right? The tail is called the initial point. And where the tip ends is called the terminal point. Let's say we have another vector, B, that looks like that. And suppose we want to add these vectors together. So what you do is you take the vector A, the first one here. So this is my A. And then I put B, I put the initial point of B on the terminal point of A, like this. And then I complete a parallelogram by adding two sides that are parallel to A and B, like that. So here's A, here's B, and that's another side I added that's parallel to B, and that's a side I added that's parallel to A. Then I go from the initial point of A to the terminal point of B. So this guy right here, this is A plus B. Does that make sense? Yep. Okay, let's do another example with the same two vectors I had. So here's A, and here's B. So let's find out what, let's say, A minus 2B would look like. So let's focus on this minus 2B part for now. Think of minus 2B as negative of 2 times B. And what do you think happens if I take a vector and multiply a number by it? Right. Yeah, so this is saying that we may take B and make it twice as long. Anyone want to guess what negative does to the vector? Change direction, right. In what way? How do we change it? The opposite, excellent. Okay, so what I'm doing here is to take B, make it twice as long. So this is 2B. And then I flip the direction. And there's my negative 2B. And think of this as A plus negative 2B. Use the same parallelogram way we just did. Here's A, negative 2B. We started at the terminal point of A.